Welcome to FEMM, the Facility for Electron Microscopy of Materials at Renewable and Sustainable Energy Institute in the University of Colorado Boulder. At FEMM, our mission is to address material issues scientists face in tackling global challenges in energy, environment, computing, and beyond. FEMM hosts the state-of-the-art aberration-corrected transmission electron microscope, Titan Themis, a unique microscope in the state of Colorado, enabling scientists across the state to see the atomic structure of novel materials. Yes, we can see individual atoms, but that's not the whole story. We can focus electrons to a sub-angstrom probe, position it on an atomic column, and carry out the electron spectroscopy to identify the material's elemental composition. We can see the tiny electric and magnetic fields that make your everyday electronic devices work, and many more. Our Titan surpasses manufacturer performance specifications. It was successfully commissioned in 2019 in the section of Sustainability, Energy and Environment Laboratory Complex that is designed to accommodate highly sensitive world-class instruments. Yes, our microscope is sensitive. When you enter the room, it feels the air turbulence and the change in temperature, and our electron probe gets distracted when you talk or even whisper. But don't worry, you don't need to stay still when you acquire an image on our microscope. You can operate it from our control room and enjoy interacting with your colleagues and discussing the experiment. And yes, you can see atoms from far, far away. The FEMM Titan is connected to high bandwidth, low latency networks that enable us to control it from miles away.
We are here at Engineering Center about 2 miles away from our microscope, and we're going to see how we can operate the microscope. See here the image of the microscope room. This is live, that when we load the sample there and you can ship us the sample, we can load the sample for you there, and you can operate the microscope from anywhere where you have these set up. So exactly the same as what you are doing when you are on the microscope. Zoom in, we should be able to see some atomic resolution images. We can collect the data, and because we are not in the room, and you can see that even the light in the room, in the TEM room, went off. So even we are not in the room, there is no noise in the room. So it's going to help us to have a minimum noise, acoustic noise, have the best condition when we are not in the room, when you're operating it remotely. And you would be able to see now here, you can see the individual gold particle here, and I can even zoom in so you can see column of the atoms there.
Please reach out if you're interested in setting up a remote control system in your institute to access our world-class aberration-corrected TEM remotely. We are a shared facility and open to universities and research institutions across the nation, as well as industries. We regularly offer electron microscopy courses and are committed to educate and train our users. You can even get training on our instrument remotely. We hope to see your discoveries at FEMM.